Welcome to chapter 6. We are actually going to be working on the request system. When we are asking Twitch to do something, we are calling a web page. There are different ways to open this web page, and this web page is going to send us different types of results. To be sure that we can do it properly, cleanly every time, we are going to have a request system that will automatically do a request just with different parameters based on what we need. I have made a request file that will allow us to do requests. Welcome to the abstract request class. Abstract because just a request isn't going to be enough. We are going to need the type. But the idea we have for a request is that the user sends the request and once it's done, gets called back automatically. We are going to use Unity's web request class. That way we are certain that it's going to be compatible with everything. Unity web request. To send a web request from a Unity web request instance, so we need to create a web request instance, call send web request. So we are going to need a web request, and once the web request is sent, it returns a Unity web request async operation. This is going to hold the request that's ongoing, so we need to save it. These two, honestly, are not needed. They are just shortcuts to the operation to yield, if you want to yield it in a coroutine, and the operation, which is just an accessor to the operation. So these three variables are exactly the same. Finally, I made a shortcut to the result of the request because it's a little bit too complicated to access directly. And we have a function that is going to be called when the request is completed, which is going to use Matt-Schoen's JSON objects library, which is an excellent library. It should be provided with the code of my system, but all credits goes to him. JSON.create the result. It takes result that Twitch sent us, turns it into a JSON object that is going to be easier to read. And then whoever started the request gets sent this JSON object. Afterwards, we can forget about the callback since the request should die pretty soon. Now let's take a look at what pull request looks like. So let's check the documentation from Twitch about the API. How to create a poll. Creates a poll that viewers in the broadcaster's channel can vote on. Requires a user access token that includes the channel manage polls scope. In the previous chapter, when we ask for an OAuth token, we need to specify what scopes we need, because the user is going to have a list of everything your application wants to be able to do. If you didn't include this when asking for the token, you will not be allowed to create a poll. The URL we are going to send this request to is this one, and it's a post request. This is going to be important for in a little bit. So, a request has multiple parts. We are going to divide them in 3 parts. The first part is the header. These are information about who is asking the request and what it contains. The header is going to need authorization key, which is the key you have gotten with your authentication. It's basically the OAuth token. Client ID is the ID of your application that you got when you created the application back in chapter 4. Content type, this might change, but it doesn't seem to. The data we are going to send when we are sending data is going to be JSON. These parts are also automated in the system. There can be a request body, which is going to be the JSON. We need 3 headers and a body, which contains the broadcaster ID, the title of the poll or the question, the choices with a title, a duration, and some additional parameters. So this is what a request looks like. How do we do that? We need to store these informations in a place that's going to be handy for us. So in the library, if you have downloaded my library, I created a client class, which holds the client ID, the client secret, the authentication token, informations about the broadcaster, and basically it contains all the steps required to create a client. Let's just finish with the request first, and we'll see the client after that, okay? So let's get back to our post request. It's a class that inherits from request, which holds all the base logic of all requests. And to do a post request, we are going to need a client, since it holds the OAuth token and the client ID, the URL, which in our case is this, the parameters as a JSON object, which are all of this, a callback, a function that will get called once the request has been sent, and this is not used, but I added it, the potential query parameters, list of parameters that will be added to the URL. This constructor is actually the same constructor as this one. It calls it automatically by turning the JSON parameters into a string. The client, the URL, the content of the request, the callback once it's over, and the parameters. First thing first, we remember the callback that the user asked. Second, we are going to create the request. To create the request, which is here, new Unity web request, it needs first the URL. Second parameter is the method. So in our case, the method is post. Third, a download handler. This is the part of the request that is going to download the answer. We don't need anything particularly complicated. And a upload handler. The upload handler is the part that is going to send the data. So we need an upload handler. Upload handler row is just going to send a byte array. So we turn the string of the contents into a byte array. And this is what we are going to upload. We add the query parameters. This is a function that we have overlooked so far. But if there are parameters to the query, this function is going to add them using a for each loop by simply adding parameter 1 equals parameter 2 and parameter 1 equals parameter 2 and etc, etc. It builds a string that looks like http mysite.com/! variable 1 equals 1 and variable 2 equals beta and variable 3 equals boo-boo. And all you have provided is this. Let's get back to our post request. So when we create a post request, add query parameters. In our case, there are no query parameters required. As you can see, the URL is pure. We create the Unity web request. We use the add headers function that we created in the request class. Why didn't I mention it before? Because it's one of the complicated parts. Basically, it's going to automatically fill these 3 lines of the request. Let's check it out. It takes the web request we have created, adds authorization, bearer client.authentication token. Second, client ID, which we also have saved in the client. Third, if needed, the type is a JSON. And the headers are added. They are going to be most of the time the same. So we have created our post request. We have filled the header. We have filled the parameters, and we have created the JSON that contains the poll we want to create. Broadcaster ID, title, choices, etc, etc. Wait, we have not created this. This is true, because we are at the part that sends the request, not the part that creates the content of the request. This is going to be for later. We are simplifying all of this in order to only have to do this. I promise it will make more sense after that. Just remember that basically the part we are doing is this. We send the web request, which gives us an async operation, and when it's completed, it's going to call the onCompleted function, which is part of the request class. Once it's completed, we create a JSON based on the result the Twitch sent us, and we send it to whoever asked for this request in the beginning. We can forget this information now, because we don't need it anymore. The request has been filled. We are going to do the same for GET requests and PATCH requests, which are basically simpler information than POST, because they will never contain this type of information. They don't upload anything. So I made a simple request class. It's basically the same that we've seen before. It just adds the query parameters to the URL, creates the request, adds the headers with the authentication token, the client ID, and it starts the operation and calls back once it's done. And the only difference between a GET request and a batch request so far is that one is the type GET and the other one is the type batch. So now we have the ability to create a request, send it as a post, as a GET, or as a patch. To make things a little bit easier, I created an extension class. If you have never seen extension classes, you are in for a treat. So basically, the post, get, patch requests, all of the requests are going to need a client. They could even be part of the client class. Like if I could type my client dot send post request cuckoo, that could be great. But the thing is, if we added the request system directly into the client class would get really big. So what we do is that all of the request system is completely independent of the client, but we create a static function. You know what? Let's create a quick one. Public static void example, this client. This is just an example. And the example function now exists inside the client class without actually being in the client code. Now we have the ability to send a request. We need to get the authentication token, but thanks to DLCat, we already have a code that's capable of getting an authentication token. And we need a place to store the client ID, etc., etc.